In 11a, you're asked to find the tangent to the function x squared minus 6x plus 3 that's parallel to y is equal to 4x minus 2. The first thing you should note is that the gradient of the line we're referring to is 4. First thing I've got to do is to find the derivative. Once I've done that, I'll solve it for x for when is dy over dx is equal to 4. So when dy over dx is equal to 4, so therefore 2x minus 6 is equal to 4, and x is equal to 5. So I've got my x value, I've got my gradient. I now have to find the y value at that point. So I substitute back in to the original function. So I therefore have the point 5, 2, and I'll find the gradient, the equation I should say, at that point. Y is equal to mx plus c. C is equal to negative 22. And my answer therefore becomes y is equal to 4x minus 22. Parallel the x-axis means the gradient is equal to 0. So working with the derivative before, I solve that for when it's equal to 0, and that will give me x is equal to 3. The y value, well, what I have to do there, I have to plug x is equal to 3 into the original expression. So 3 squared, take 6 times 3 plus 3, and y is equal to negative 6, or the point 3, negative 6. As the gradient is 0, the answer is going to be y is equal to negative 6 as my final answer. Now, when we start talking about a perpendicular, in this instance we mean the normal. First thing I've got to do is to transpose that, so I've got a y is equal to mx plus c format. So y is equal to negative a half x plus a sixth. Now the gradient is equal to negative a half. Now, as I hope you remember, the gradient of the tangent times that is equal to negative 1. So therefore, negative 1 divided by negative a half gives us the gradient of the tangent 2. I can now work with that in order to solve and then find the x value. So when the derivative is equal to 2, I've got 2x minus 6 is equal to 2, and x is equal to 4. So I've got the gradient, x is 4. I'm now going to substitute into y. And y ends up being negative 5. So I've got m is equal to 2, to 0.4 negative 5. I then find the value of c. So I've got my c, I've got my gradient. So I write my final answer out as y is equal to 2x minus 13. Now I should say this is very much at the extreme of the course, but worth a while having a look at this question.